Yes.
What did I do?
Distracted me.
Maybe it's education.
You're so irritating.
The first step, right? Obviously, we need a graph on here. Hey, shh, hush, up in front. Okay, so if I'm looking at this, graphing my first line, Luis, please don't interrupt me. Starts at -2. So I go to -2 on the... Starts at -2. And what's the slope right here? What's the slope of this line? So if it's x, we're looking at what's in front of x, which here is just like 1. So that means 1, or we can also write it as 1/1. Move your seat if you're going to talk. Okay. So from right here, my slope is up 1/1, up 1/1, up 1/1, up 1/1. Ooh. And I draw my line. Okay. And that's the first line. Okay. Now our second line, again, the graphing piece, nothing new. That's old news. We should be able to start at 7 with that second line, and then the slope is -2/1. So I'm going down 2/1, down 2/1, down 2/1, boom. And right there, where those two lines cross, is the solution to our system. I know then the solution right here is 3, 1. That's by graphing. Okay, to be really specific, there are 4 ways that we can solve a system. Graphing is one of them. Okay. I'm not even going to ask you guys about what happened. Maybe I'll just reteach you. Yeah. Okay. So we're going to do 2. So we did graphing.
She had a great expression though.
We did graphing. I'm not asking. Hey, shh. I'm not asking. Okay. We are going to look at a few examples and then talk about why in the world we're even dealing with systems and where they show up in a business problem. Okay, so let's talk about that. I'll give you maybe 3, maybe 4 examples if we need it. Okay, so let's talk about A3 systems, and I'll go quickly over what I hope we're doing. Yes, sir. What?
So Ms. Anderson said the reason why you guys teach this is because it's like buying a house. For use this math as buying a house.
You can use this house in buying you can use systems in buying a lot of things, which is what we're going to spend our time doing next week. So looking at how you make good decisions when you're buying stuff using systems. Hey, heads up, please. Don't at me. Okay, the first thing, there are, again, I said 4 different methods. Technically, I think of it as 3, but we're going to be specific and call it out as 4. Do you want to call it 3 or you want to call it 4? What do you want to?
4.
Okay. We already did graphing. Graphing is pretty straightforward. Apparently, the substitution piece we're having a little bit of a tough time with. That's what we're going to call it a different name then. We're going to call it equal values. If I'm writing, you should be writing. If I'm writing, you should be writing. Sitting right next to me. Go. And as an example, we're just going to use the problem we just had. So some of you maybe already did it. We're just going to kind of reverse a little bit here. X minus 2 was the first equation, and negative 2x plus 7 was the second equation. And if I'm trying to solve this, we already know the answer. Okay, we already graphed it. We already know the answer. But as you're about to see later today, is that graphing is not usually a very good method, and especially when we get in a business context, right? Graphing our revenue and graphing our expense, we're not going to be able to graph and find this beautiful little point. Okay, so the equal values method says you have two things like that are equal. They're both equal to y. All right, so this is pretty straightforward. If I am the same height as Quinn, and Quinn is the same height as Akash, let's just pretend, okay? Right, if I'm the same height as Quinn, and Quinn's the same height as Akash, what does that mean about me and Akash?
We have the same height.
Yeah, okay? We would be the same height though, right? That it would mean like if, you know, if I'm the same to you and you're the same to someone else, me and that other person are then also the same, okay? And that's the same thing, the same reasoning that we're using right here. Okay, x minus 2, what is it equal to? What's x minus 2 equal to? Y. Look, see? Look. See how it says y equals x minus 2? X minus 2 is equal to y. Because it is equal, we can go ahead and take this x minus 2 and put it for that y, because x minus 2 is equal to y. So I can write it in place of y. So that's going to be our very first step, and what it's going to look like is that we are going to set the equations equal. Okay? We are going to set the equations equal. So I'm going to have again, I'm writing it out as x minus 2 is equal to negative 2x plus 7. I took this x minus 2 and I put it in place of y. So I had x minus 2 equals negative 2x plus 7. Now that I have an equation, notice the y's are gone. I'm only left with x's right here. So I'm going to go ahead and go on to my second step, which is solving for x. You guys are wonderful little solvers. So go ahead, make sure, move this negative 2x over to the other side. Bring the x's over.
Where you get the equal sign from?
Right here.
So the y's disappear and then the equal sign, right?
Well, so here's what happened again. Okay.
I thought
Well, if
it
they're
was
equal.
positive.
Okay, let's say this another way. Here's what it said. This says, let's use heights. I'm the same height as Kalasia, and it's fun for me. And I'm also the same height as Manuel. Okay, so look, I'm Y. Here's me, I'm Y. Okay, I'm the same height as Kalasia, and I'm the same height as Manuel. So what does that mean about Kalasia and Manuel? No, be for real. It means to be they're the same height, right? So that's the exact same thing I'm using right here. If these are both equal to y, then they are equal to each other. Okay, if these are equal to the same thing, then they're equal to each other. All right, so we set that equation up. Now you guys finish solving. Take 45 seconds. Flip that 2x over to the other side. Justin. Shh. So we have 11x minus 5 equals 6. Okay, I seem to always bring my x's to the left side if I can. Now then I need to add 5. I get 11x equals 11. So I divide by 11 and get x equals 1. Okay. That is the bulk of the problem, finding out x. That last step, right, to find out what y is, because you need an x and a y to be a point on a graph, is taking this and plugging it in to your equation.
Can you show us?
It can be the bottom one if you want.
Can you show us? How'd you plug it in?
Of course I'll show you. Stop being ridiculous. Okay, nope. So I would have 5 times 1 minus 5. 5 times 1, 5 minus 5, 0. So we get our point, 1, 0. Okay, x comma y. Okay. That's equal values. Next one. So we know graphing, we know equal values, and then on Friday, in theory, we talked about substitution specifically. And I think this will be our last example. Okay? So for substitution, I am going to do one really big example. Again, this is going to be our one really good substitution example, so please make sure you have it in your notes. Okay, here it is. Y equals 6x minus 11 and negative 2x minus 3y equals negative 7. This is what homework 3.5, a lot of the problems look like. This is absolutely, these are the hardest problems that will be in this unit. And we're all going to work to practicing until we feel like they're easier. Okay? In this unit, substitution is, I think, the hardest method. But okay, good. I'll give you a really hard one then. All right. So again, here is going to be a little different. Okay. What is 6x minus 11 equal to? Okay. It is equal to, if I look, it's equal to y. Since it's equal to y, that means I can take 6x minus 11 and I can replace y. Because they are equal, because this is equal to y, I can plug it in or substitute it in place of y. So that first step is going to be to substitute 6x minus 11 for y in our second equation. What? You are solving for x and y. So sometimes we solve for x first. We'll get to next week solving for y first, and then we'll just go. That'll be great. Okay? So, again, I'm going to rewrite this equation right here, this bottom piece. I'm going to rewrite it except for the y. Instead of the y, I'm going to write this stuff. So, ready? It starts with a negative 2. So my first step, right, is negative 2. Then there's an x. Then there's a minus. Then there's a 3. And now I get to the y. And I'm not writing y. I'm writing, instead, 6x minus 11. And putting that equal to negative 7. Yes. You must put it in parentheses because of the distributive property. So look at this equation, right? They're exactly the same. There's a negative sign. There's a 2. There's an x. Then it says minus. Then there's a 3. The only difference is that instead of y, I write 6x minus 11. Other than that, they're entirely the same. Equals negative 7. Okay? And that's good. If you get an equation that only has x's, that's a good sign. Because now our second step is to go ahead and step 2, solve for x. I said this is hard because this equation has a lot of steps. Right? The first one being, what do we have to do with this negative 3? Good word. Both of these things. That's why we need the parentheses. Both of these things need to get multiplied. What are they getting multiplied by?
3.
Don't say 3.
Negative 3.
Negative 3. The whole thing. Negative 3 is getting distributed, boom, to both of them. Okay? So I'm left with negative 2x. Negative 18x And then negative 3 times negative 11 gives you positive 33 is equal to negative 7. Highlight terms. Good, whispering. Okay. These are on the same side. Don't try and flip them. Don't try and do anything crazy. They're on the same side. You're just straight up combining them. Negative 2 and negative 18. You should get negative 20 x plus 33 equals negative 7. Look how beautiful this problem is. I love math. Look, Yolanda, how you feeling? You want to tell me what to do next?
She's full of text messages.
Don't call her out. She's going to redeem yourself. What do I do right here? Oh, that was good. Minus 33 to both sides. Boom. Negative 20x equals negative 40. Elijah, what do I do? My Elijah, how your voice has changed. Yeah. Elijah, what do I do?
Don't you divide it by 20, negative 20?
Yeah, good call. Divide by negative 20, and we get x equals 2. If that wasn't enough, dear goodness, are we done? No. Still got to plug it in, okay? Not even done. Not even done. What are you doing? Gosh. Okay? If only we were done at that point. We're still not. Okay. Still not. Here's what you got to do. Take this. Where's it going? All the way to the top. Plug it in all the way to the top. And have enough room. Okay? Some of you guys, I don't really care how you do this. Some of your mental math is good. Right? Like, Kalasia, you have mad number skills and you can plug it in and you go, 1. Right? Okay? Some of you are not, right? You're like, oh, wait. I need to write down. Okay? And I don't care how you do it, but you should get to the point where you're doing 6 times 2 minus 11. Which is 12 minus 11, which is 1. Make sure you write it as an ordered pair. Whew. Whew. Oh gosh. Okay. There's all 3 days of math that you're supposed to learn last week. Good.
You just did everything. It was so.
Are we all exhausted as much as I am? Great.
Yeah, she did a lot. She made it.
Okay, I don't care how she made it. I'm just saying. So we're good. Now. Okay? So this is the point where those lines intersect. This is the point where those 2 lines intersect. Okay? Okay. Are we okay moving on now? Yeah. Okay, I think I need to be done talking to you. That's what I think. To get 349x equals 1392. And what do I need to do with that 349? Bye. 399, is that true?
Yeah.
Thank you.
Okay. That would be 399 shirts. Here's what you have right here. Your homework. That first problem needs to be done and done correctly with a stamp. So when you have this first problem done, I'll happily give you a stamp so long as it is correct. If you can't finish it, you're not getting full credit. Is revenue
Revenue? How much you make?
is how much you make, right? The revenue is how much you make, and then what's the expense?
What's your item?
How much it takes to make it.
How much it takes to make it, or how much you have spent? Okay? So oftentimes, now, you can go at this from a really simple perspective, and you can go at this from a really complicated perspective. Okay? For instance, most businesses, they don't just have the expense of one printer and then buying that item. Okay? Most businesses have as expenses, I don't know, rent for their facilities, utilities, their salaries of all their employees. We could make this an extremely, extremely complicated problem. What we're going to look at right now is our t-shirts. Okay? So let's do this example real quick. With Vapor t-shirts. Okay, so let's look at this. What is our revenue for t-shirts? How much do we make? How much do we make? I'm not talking about subtracting, not talking about anything. When we sell a t-shirt, we make $10. Okay? So our revenue right here is 10x.
Why is X?
What? Yeah.
Black Friday's coming around.
Okay? See? Watch out. Okay? Your revenue is, we could change this to 12, 15, whatever. We have some ideas where we might be selling shirts for a little more. More on that later. But the revenue for shirts is $10 in general. Okay? Now, our expense equation. All right, this is our revenue equation. And it says we make $10 a shirt. And this is our expense equation. How much did we charge on that press? How much did that press cost us? $1,392. Anyone know off the top of their head how much a shirt costs us?
I don't know, roughly.
641.
I was close. I said 7.
41 or 51?
41.
Okay. 651x.
Roughly 7. So do you guys involve the shipping amount or no?
This is not involved in shipping, no. Okay? But we could go ahead and add on here plus shipping. We could go add on here expenses plus how many we mess up. We could put a lot of stuff in our expense equation. The ink, we haven't even talked about the printers yet, right? So like I said, this can get increasingly complicated.
Very.
We're starting out just simple for a second. Now, the break even happens, like we said, when your revenue equals your expense. In other words, you have a system of equations. Right? I want to know when your revenue equals your expense. So to set that up, again, we're setting up revenue equals expense. That's what we're setting up. Our revenue is $10 a shirt. Our expense is 651x plus 1392. If I'm writing, so should you be. Yeah. You should be too. But that's what's wrong. That's still valid. It's still valid. Huh? Yeah.
It could have been phrased better.
It could have been phrased worse too.
I thought we phrased it this way. Quinn, you should be writing it.
Okay.
Okay.
You should be turned around and focusing.
Luis. Here's an equation right here. This equation, in terms of revenue and expense, go ahead and solve that equation. Ed? Hey. I'm going to go over this one a little quicker, pointing out some key things. The first thing, that first step, again, you have two different things that are equal to the same thing. They're both equal to y, so these two things are equal to each other. Okay, so I'm saying this is equal to this. And that's the equation we're solving. And again, I see a lot of people doing there's like 4 different options. There's not one way you can do this. Okay? The setting it up part, thinks, is the hard part. Well, I'll say the setting it up part is the important part, because if we don't set it up correctly, we have no chance of solving it correctly. Okay? Huh? No. All right.